I think one term which really confuses a lot of students is carbon sink. So the idea that the ocean acts as a carbon sink. Now, obviously, these two things are not the same, and that is not what we are talking about. It is not a sink where we can turn a tap on and we can let things run out. A carbon sink basically means something that will soak up the carbon. It is a storage method of the carbon, and it is the way that nature counteracts, if you like, variation in the amount of carbon in the atmosphere. And so let's have a look in a bit more detail. So carbon dioxide is actually soluble. So it is a soluble gas, and it will dissolve in water. That's what soluble means. So soluble in water, and that means that CO2 will dissolve into the ocean. This means that as CO2 goes up, so let's draw a diagram for it actually. Let's pretend that this is the ocean, and if we have lots of CO2, so we have loads of CO2, let's just call them these white dots. If we have loads of it, some of them will go into the ocean and they will dissolve in the ocean. That reduces the amount of CO2 we have left in the air. So we've counteracted the change. But what about if CO2 levels globally went down? Well then, the sea, containing lots of this CO2, and a lot of it is dissolved in there in a soluble form, some of it will then just leave and become CO2 gas again. And this means that we've counteracted the change in both ways. And that is why the ocean is known as a carbon buffer as well as a carbon sink. So we can say it acts as a buffer. Now if you want to look into a bit more detail about what's happening here, we can form carbonates, and we can also form hydrogen carbonates. Hydrogen carbonates. Those things will form in the sea. So CO2 will dissolve in the water, and then reactions will occur which form carbonates or hydrogen carbonates. Carbonates are insoluble, mainly. Some of them are soluble, but many of them are insoluble. And the main example of that is calcium carbonate. Obviously, you know that that makes up a lot of limestone. Calcium carbonate is the major component of limestone, and so if we form calcium carbonate in the sea, that will be deposited as sediment at the bottom of the ocean, and obviously that is no longer dissolved in the sea. It's now become a solid itself, and it's at the bottom of the ocean. A hydrogen carbonate is soluble, however, and that might be calcium or magnesium hydrogen carbonate, and that would be HCO3, like that. So let's say magnesium hydrogen carbonate, that would just be dissolved in the ocean, and it would be travelling around, as you can see with these white dots here. And so they're the different ways that the ocean can deal with excess CO2. So why is it that recently global warming has been such a big issue, and people are saying use more green technology, because if the sea can just deal with it, then what's the point? It's just a waste of money. Well, the point is that the sea is now becoming less and less able to cope with the increased amount of CO2 that we are releasing into the atmosphere. And now if we take a look at this graph, this is obviously one I've drawn myself, but it pretty much shows the trend. If you've got CO2 concentration on the y-axis and the year on the x-axis, between 1960 and 2000, the CO2 concentration has been going up and up and up and up and up and up and up. And the reason we've got these jagged lines is because plants are seasonal organisms, and therefore, depending on the season, there are going to be different amount of plants that are flowered and that are carrying out photosynthesis, or some of them might be dormant and not really doing anything, and so they will contribute less to reducing the amount of CO2. So that's why you see such a fluctuation as is seen by this jagged line. But anyway, the overall trend between the years is that the carbon dioxide is going up. Now there are various different theories and reasons why the oceans are now not able to cope with the amount of CO2 we're releasing. One of them is that CO2 is acidic. This is a fact. Carbon dioxide is acidic. When you dissolve it into water, you can form what is known as carbonic acid. Okay? We are seeing a trend that coral reefs are dying due to the more acidic conditions. Now, as more and more CO2 is being released and the ocean is taking in more and more CO2, that is slowly but surely causing the pH of the ocean to go down, to become more acidic. That is because there is more carbon dioxide in the ocean, which is causing this to happen. Now, coral reefs are very sensitive to pH. They have a certain pH in which they will grow and they will thrive. But if it's too acidic or even too alkaline, then they will start to die. And we are seeing coral reefs dying because this overly acidic conditions as a result of the CO2 is causing them not to be able to cope. And so that's just one example of how we can see that nature is not really coping with the level of CO2 we're releasing. And so finally, why is it that burning fuels is releasing so much CO2? Because if you think the amount of carbon in the atmosphere and locked away in the earth is always going to be constant because it's going in a cycle, as we saw in the carbon cycle, from one place to another. Well, the point is, at any given time, a lot of the carbon is locked away in rocks or underground in dead material and everything else. The fact that we are burning the fossil fuels means that less and less carbon is being stored in those fossil fuels, which would normally be, inside the Earth's crust and therefore out of the way and not able to become CO2. Now we are burning so many fuels, all of those fossil fuels containing carbon are releasing their carbon into the atmosphere as CO2. And so if you remember our carbon cycle, this arrow here is becoming more and more and more prevalent because we are doing more and more of this, but obviously all the other processes aren't increasing their speed at the same rate. So that means that there is an imbalance here and we are getting an excess carbon being given off as CO2, whereas the arrows which are going away from CO2, such as photosynthesis, well, they are not actually increasing at the same rate. So that means you're getting more carbon dioxide given off, but on the flip side, we don't have the same amount of carbon dioxide being taken back in. So that is leading to an imbalance, which is not normal, and which is why we're seeing these unnatural things in nature coming from our increased release of CO2. So I hope that's helped you sort of understand why CO2 being released is a bad thing and why oceans as sinks are no longer really able to cope. If you were to still think of it as one of these sinks, a traditional sink, well, this sink is now overflowing. The sink is now not able to hold the capacity of CO2 that we are pumping into it. It's overflowing and this is causing problems. Okay, so please feel free to leave a comment below or send me an email if you have any questions, and I'll see you in the next video.